Hello. This video is an overview of the Snowload framework I've developed to programmatically generate the Snowflake objects which allow source data files to be automatically ingested and merged into historical, fact, and slowly changing dimensional tables. There's a bit of conceptual information to cover here, but you'll be able to see detailed demonstrations of the processing in subsequent videos in this series. In this chart, the objects with the green stars are created by the code generation process I'll be talking about in the next video in this series. By the way, I'm assuming you're either a current Snowflake user or have some familiarity with the Snowflake object types. If not, please check out the excellent documentation in Snowflake's website. The Snowload framework can ingest data files from either AWS or Azure. All of the processing and staging tables live in the load schema, and the historical fact and dimension tables are in the transform schema. The Snowload framework defines each source file type with a unique entity name. As files are copied to a cloud storage location referenced in the stage object created by the CodeGen process, they are automatically ingested into a staging table associated with the source entity name. All of the staging tables have an identical format, which consists of a variant column populated with JSON containing the data keys and values, sandwiched by input file and processing metadata. Source data accumulates in the staging tables until it's archived by a daily scheduled task. The CodeGen process creates views on top of the staging tables to flatten the JSON into relational format. A raw view contains the non-data type columns as they came in from the source. The typed view casts the column values to their proper data types. Any value that can't be properly cast is assigned a null value. The type view is a source for the transformation processing which updates the historical fact and dimension tables in the transform schema. The view contains data type errors. It also lists any values associated with columns which have been defined with a not null indicator, but which contain nulls either because they came in that way or were converted to null by a typecasting error. The CodeGen process creates a stream for every staging table. The stream acts as a trigger for downstream processing to indicate that new data is available for transformation processing. A task object is created for every staging entity which runs every minute. It queries the stream via the no-cost cloud service layer function system stream has data, which returns true if the underlying staging table has new data. If there is new data to process, the task calls the task handler SP-transform entity and passes the entity name as a parameter. SP-transform entity calls the transform procedure created by the CodeGen process, which will update the transform fact or dimension table with the new source input. By default, source input files are processed sequentially within entity in ascending file name sequence to limit the risk of back-leveling data in transform processing. An alternative SP-transform entity merged procedure is used when multiple source input files can be processed in parallel without concern for collisions. The file list table is used to keep track of transform processing and is aware of the status of every source input file. As the transform processing runs, messages are captured to the framework's procedure log. The result of processing are updated fact and dimension tables in the transform schema available for consumption APIs. A separate video will detail the transform processing for facts and dimensions.